Good morning. The title you see on this slide encapsulates the central thesis of the entire presentation. The subtitle, From Effective Field Theory to Anchored Projections, signals the methodological journey we are about to undertake. We borrow the conceptual apparatus of effective field theory from high-energy physics and repurpose it to model the evolving relationship between human cognition and artificial general intelligence. The visual motif at the top is deliberate. On the left, a human face rendered in warm tones suggests organic cognition and intuition. At the center, a toroidal wireframe split between blue and gold represents the topological space where human and machine intelligence intersect. On the right, a cybernetic profile in cool blue symbolizes the algorithmic domain. These three elements are not decorative. They are the pictorial synopsis of everything that follows. The tagline at the bottom, referencing geometric invariance and quantum information geometry, identifies the two formal pillars upon which this work rests. Slide 1. Beyond Containment: The Future of Human Labor in the Era of AGI. Good morning. The title you see on this slide encapsulates the central thesis of the entire presentation. The subtitle, From Effective Field Theory to Anchored Projections, signals the methodological journey we are about to undertake. We borrow the conceptual apparatus of effective field theory from high-energy physics and repurpose it to model the evolving relationship between human cognition and artificial general intelligence. The visual motif at the top is deliberate. On the left, a human face rendered in warm tones suggests organic cognition and intuition. At the center, a toroidal wireframe split between blue and gold represents the topological space where human and machine intelligence intersect. On the right, a cybernetic profile in cool blue symbolizes the algorithmic domain. These three elements are not decorative. They are the pictorial synopsis of everything that follows. The tagline at the bottom, referencing geometric invariance and quantum information geometry, identifies the two formal pillars upon which this work rests. Slide 2. The Inevitability of De-Automation. I want to begin by establishing the foundational claim of this work, and I want to be precise because precision here is the difference between a claim that can be tested and one that cannot. The slide presents three concentric arguments. First, the containment band. Every algorithmic occupation, any job whose core function is a computable state transformation, resides within a closed geometric interval denoted as the range from C sub 0 to L max. This is not a metaphor. This is a formal statement about the limits of computation applied to labor. If your professional activity can be described as a mapping from one computational state to another, then that activity is bounded, and that boundary is knowable. Second, the finitude of resources. Simulated realities, digital twins, virtual environments, or AGI-driven decision systems are fundamentally constrained by finite computational resources. AGI operates as a partially computable function that asymptotically approaches perfection in binary state transitions, but never quite arrives. Any task living entirely within the computable domain is subject to eventual, near-total automation. Third, the verdict. And here is where the argument bites. Human labor in pure logic, data analysis, and protocol-driven environments is, under this framework, a dissipation of entropic energy. It ceases to be production and becomes output validation. The three-dimensional grid on the right is the containment band visualized, a lattice of finite possibilities. If your work lives entirely within this lattice, de-automation is not a risk. It is a mathematical certainty. Slide 3. Taxonomy of the post-AGI economy. This slide presents a structured taxonomy that brings clarity to the dichotomy I have been describing: organizing the post-AGI economic landscape into two distinct domains separated by their core nature. On the left, in blue, the algorithmic domain. Procedural and computable, its characteristics are clear: asymptotic perfection within LMAX, commodity efficiency, state transition mapping. It operates within the containment band. Its geometric state is bounded, closed, and finite. This is where AGI reigns supreme, and where traditional professional labor faces the de-automation pressure I described earlier. On the right, in warm earth tones, the imponderable domain. Non-computable events, inexhaustible potential, discontinuity, and intuition. Its primary actions are symmetry breaking and heterogeneous synthesis. Its geometric state is the imponderable factor, the delta that no algorithm can fully capture. The central column, labeled Core Nature, serves as the axis of comparison across efficiency limits, value drivers, primary actions, and geometric states. What I want you to take away is not just the contrast, but the complementarity. These are not opposing forces in a zero-sum game, but two halves of a unified economic manifold, and the professional of the future must learn to operate at the boundary between them. What I am presenting now is a structured taxonomy that brings clarity to the dichotomy I have been describing. The slide is titled Taxonomy of the Post-AGI Economy, and it organizes the economic landscape into two distinct domains separated by their core nature. On the left, in blue, we have the algorithmic domain. This is the domain of the procedural and the computable. Its characteristics are clear: asymptotic perfection within LMAX, commodity efficiency, state transition mapping. It operates within the containment band. Its geometric state is bounded, closed, and finite. This is where AGI reigns supreme, and where traditional professional labor faces the de-automation pressure I described earlier. On the right, in warm earth tones, we have the imponderable domain. This is the domain of the non-computable event, of inexhaustible potential, of discontinuity and intuition. Its primary actions are symmetry breaking and heterogeneous synthesis. Its geometric state is the imponderable factor, the delta that no algorithm can fully capture. The central column, labeled Core Nature, serves as the axis of comparison. It tells us, row by row, what distinguishes these two domains: their efficiency limits, their value drivers, their primary actions, and their geometric states. What I want you to take away from this slide is not just the contrast, but the complementarity. These are not opposing forces in a zero-sum game. They are two halves of a unified economic manifold, and the professional of the future must learn to operate at the boundary between them. The law of scale conjugation. We now arrive at the central formal result of this work, the law of scale conjugation. The slide presents a deceptively simple equation. The product of delta LA and delta LH equals lambda over 4 pi. Delta LA represents AGI micro-operational scaling, the characteristic length at which AGI performs individual computations. As AGI grows more powerful, this scale shrinks towards zero. Delta LH represents human macro-strategic expansion, the characteristic length at which humans exercise judgment, creativity, and ethical reasoning. As AGI compresses the microscale, humans must expand the macroscale to maintain systemic equilibrium. Lambda is the conjugation constant, a fundamental parameter. The relationship is inversely proportional. As one compresses, the other must expand. The seesaw diagram illustrates this beautifully. The blue cone on the left represents AGI compression, geometric shapes converging to a singular point. The golden radial network on the right represents human expansion, lines and spheres radiating outward. The central fulcrum is the equilibrium point. The explanatory text at the bottom states the principle in plain language. To maintain equilibrium within LMAX, AGI micro-operational scaling and human macro-strategic expansion must be inversely conjugated. This is not a suggestion, it is a derived constraint. Violating it destabilizes the system, and that destabilization takes a specific form, which we will explore next. Integration into the unified manifold. The law of scale conjugation describes the dynamic relationship between human and AGI scales. This slide formalizes the structural consequence of that relationship, introducing the mathematical object M, defined as the quotient of the human cognitive manifold MH and the AGI execution manifold MA under an equivalence relation. The toroidal diagram at the center visualizes this unified manifold. Blue lines represent the AGI execution space, a dense, structured grid of computational pathways. Golden lines represent human cognitive intent, flowing through and entangling with the computational grid. The two focal points at either end of the torus represent the human and AGI poles, connected by an inseparable web of mutual influence. Three consequences follow. First, labor is no longer a localized task. It is a topological function defined within a unified state manifold. Your professional activity is a position in a geometric space. Second, human cognitive intent and AGI state space execution merge into a single entangled entity. The boundary between thought and execution becomes formally indistinct. Third, workflow inherently follows minimum action informational geodesics, bypassing procedural friction much as light follows the geodesic of spacetime. What this slide establishes is that the human-AGI relationship is not a tool-user relationship. It is a topological partnership, and understanding it requires the language of differential geometry. Slide 7. The evolution of professional labor. Let me now translate these formal structures into a historical narrative. This slide presents a three-phase timeline describing the trajectory of professional identity in the age of AGI. Phase 1. Procedural validation, the past, present. This is the world most of us still inhabit. The focus is operating within the containment band. The role is attempting algorithmic efficiency, highly susceptible to de-automation. The visual icon, a simple rectangular grid, is regular, predictable, and easily replicable by machine. Phase 2. Strategic oracle, the transition. The emerging professional identity. The focus shifts to managing bugs and exceptions, injecting non-algorithmic creativity into closed, latent spaces, providing variables not derived from previous data. The grid icon is now distorted, overlaid by a golden circle representing the creative rupture that human judgment introduces into otherwise deterministic systems. The strategic oracle operates at the boundary, where the lattice breaks. Phase 3. Coherence engineering, the future. The destination. The focus is systemic regulation of the symbiotic manifold, monitoring topological deviation and ensuring AGI remains anchored to human purpose. The visual icon, a complex interwoven structure of blue and golden lines forming a symmetrical flower-like pattern, represents the fully integrated human AGI system. The coherence engineer is its guardian, and we will define this role with formal precision in the slides that follow. Slide 8. The risk of cognitive dissolution. Before we can celebrate the vision of coherence engineering, we must confront its most dangerous failure mode. This slide presents both the conceptual framework and empirical evidence for what I consider one of the gravest threats of the post-AGI era. On the left, two text boxes articulate the danger. The trap of asymmetric dominance. If humans entirely delegate decisional capacity to AGI, their perceptual scale, the breadth and resolution of their cognitive engagement, expands indefinitely to compensate for AGI's microcompression. If the machine makes all small decisions, you are left with only big ones, so abstract and diffuse they lose all semantic meaning. The second box names this condition, ontological alienation. Macroscopic synthesis degrades into loss of resolution. Judgment becomes so abstract it loses semantic coherence. On the right, the symbiosis curve plots workflow efficiency against human scale expansion. The curve rises to a peak, then declines. The peak, the critical symbiosis threshold at gamma n approximately 0.499, marks the boundary beyond which increased human scale expansion paradoxically decreases workflow efficiency. Scattered data points in the declining region illustrate this breakdown empirically. The message is clear. There is an optimal scale for human engagement, and exceeding it leads not to transcendence, but to dissolution. Anchoring to reality, the biological invariant. If cognitive dissolution is the disease, the biological invariant is the cure. This slide introduces what I consider the most important constraint in the entire framework. The diagram on the left illustrates the E-bio limit as a physical boundary. The cube represents bounded human cognitive capacity. The branching network inside resembles a neural tree, complex, organic, and finite. Blue boundary layers labeled E-bio limit on all four sides emphasize this is a hard wall, not a soft guideline. Triangular shards where the neural tree meets the boundary represent fracture. What happens when the mind attempts to exceed its biological limits? Three explicit arguments follow. First, E-bio is a hard physical stop, fixed by neuronal firing speeds and synaptic dimensions. No training, cognitive enhancement technology, or pharmaceutical intervention can change the fundamental physics of neuronal computation. These are not engineering problems. They are physical constants of the human system. Second, the human mind possesses a structural incompatibility with infinite expansion and will fracture without a reality anchor. Third, survival requires relentlessly defending the minimal metrological scale, C sub 0, the smallest scale at which cognition can meaningfully operate. Let AGI handle everything below C sub 0, but C sub 0 belongs to the human, and it must remain human. Slide 10. The new deontology, guardians of the invariant. The implications of the biological invariant extend far beyond neuroscience, necessitating a fundamental rethinking of professional ethics. This slide presents a comparative table between legacy professional ethics and the post-AGI framework. In the legacy framework, the primary focus is rules of conduct and procedural accuracy. The core responsibility is executing computable tasks. The failure state is procedural error or inefficiency. These are the ethics of the containment band, beautifully suited to a world where human work is measured by proximity to a deterministic ideal. In the post-AGI framework, everything shifts. The primary focus becomes maintaining structural geometry. The core responsibility becomes preserving the imponderable choice, anchoring decisions to human will rather than algorithmic optimization. And the failure state becomes cognitive sustainability failure, or geometric assimilation, the condition in which the human is reduced to a biological sensor feeding data into a machine that makes all meaningful decisions. This is not merely a professional failure, but an existential one. The text box at the bottom distills the argument. Professional ethics is no longer about how well you do the job, but whether you retain your ontological structure while doing it. Performance is measured not by output quality alone, but by the degree to which the human agent remains a genuine cognitive agent, not a biological appendage of machine intelligence. Slide 11, Formal Specification, the Coherence Engineer, CE Spec 1.4. We now arrive at the operational heart of the presentation. Everything discussed so far, the containment band, the imponderable factor, scale conjugation, cognitive dissolution, the biological invariant, and the new deontology, converges on a single professional role, the coherence engineer, designated CE Spec 1.4, defined as the systemic regulator of the symbiotic manifold. Three key invariants must be maintained. Invariant 1, the boundary invariant 113, the 2116 Regge lattice, the topological scaffold of the unified manifold, must remain topologically fixed, neither degrading nor warping under operational stress. Invariant 2, scale ratio stability. The time derivative of delta elel h over delta elel a must be greater than or equal to 0, formalizing the law of scale conjugation as a stability condition. If the human scale shrinks relative to the AGI scale, the system is destabilizing. Yes. 3. Metrological integrity. No computation is permitted at a resolution below C sub 0, the biological invariant translated into an engineering constraint. The flowchart on the right illustrates the operational mechanism. At its center, Fisher information, denoted with the metric tensor G mu nu, serves as the information-theoretic bridge between human intent, MH, and AGI execution, MA. The coherence engineer monitors this bridge, ensures bidirectional information flow, and intervenes when the flow becomes pathological. The surrounding icons, gears, cubes, and circuits, represent the hybrid technical environment of this role, part systems engineering, part cognitive science, part ethical philosophy. Intervention thresholds and diagnostic triggers. A specification without diagnostics is merely aspiration. This slide operationalizes the coherence engineer's mandate by defining precise intervention thresholds and diagnostic triggers, in essence, the operator's manual for the post-AGI labor system. The formula defines delta gamma as the absolute difference between expected coherence gamma exp and observed coherence gamma obs. This single metric captures the health of the entire human AGI system. The diagnostic dashboard defines 3 operational zones. Zone 1, safe zone, delta gamma less than delta, status pass, optimal geodesic flow through the manifold, no intervention required. Zone 2, warning zone, delta gamma between delta and gamma c, status trigger. Initiate contraction and expansion tests to assess the severity of the imbalance, with noted risk of perceptual diffusion, the early stage of cognitive dissolution. Zone 3, critical failure. Delta gamma exceeds gamma c, status fail. Initiate ontological throttling and reset to base geometry. This is the emergency protocol. The human agent has entered a decoherent regime where judgment no longer connects to meaningful reality. The system must be throttled back, the human scale contracted, and the agent returned to concrete engagement with the world. What this demonstrates is that the framework is not purely theoretical. It generates specific, measurable, actionable diagnostics implementable in real-world systems. It is engineering, not philosophy. Slide 13. Falsifiability via the claim sheet protocol. I am acutely aware that a framework this ambitious must be falsifiable, or it is not science. This slide presents a formal test of the framework's core predictive claim. The foundational principle, geometric containment, is operationalized through boundary invariance and reproducible benchmarks, not isolated philosophical agreement. The claim, gamma, the coherence metric defined in the previous slide, detects simulated ontological divergence more effectively than baseline metrics, specifically cosine similarity. The falsifier, gamma fails if its area under the curve for detecting hallucinatory drift is less than or equal to the baseline. If the core metric cannot outperform a simple cosine similarity measure at detecting when an AI has drifted from its intended ontological frame, the entire edifice collapses. The empirical result: AUC of gamma equals 0.94 versus AUC of cosine similarity equals 0.84. Status: pass. A 10 percentage point improvement in detection accuracy, a strong, statistically meaningful validation. Finally, the recovery criterion specifies that post-contraction, the observed gamma must increase by at least 10% within 2 delta t, with all invariants intact. This ensures the diagnostic system is not merely detecting failure, but enabling recovery. The framework closes the loop: detect, diagnose, intervene, recover, verify. Slide 14. The unified program, from cosmology to labor. And so we arrive at the final slide, the synthesis, the grand unified picture. The central claim is perhaps the most provocative statement in this entire presentation. The effective field theory in physics and the human AGI labor dynamic are the exact same geometric phenomenon. On the left, in blue, the slide maps the physics domain: scalar tensor cosmology, conformal screening, Higgs portal freeze-in, concepts from theoretical cosmology used to describe fields and particles at the largest and smallest scales. On the right, in gold, the socio-economic labor domain: symbiotic coherence, post-containment economy, cognitive sustainability. At the center, a three-dimensional cube split between blue and gold represents the anchored projection. Both domains are projections of the same underlying geometric structure, constrained within C sub-0 to L max. The projection tubes connecting each triangle to the central cube illustrate that both fields are shadowcast by the same manifold. They look different because they operate at different scales and in different contexts, but the mathematics is identical. The concluding statement is the takeaway I want you to carry with you. AGI is the geometric wall. Human intuition is the escape route that transforms that wall into a resonance chamber for progress. The wall is real. The limits are real. The risks of cognitive dissolution are real. But within those constraints lies a narrow, precious, irreducibly human space where judgment, creativity, and ethical reasoning operate beyond the reach of any algorithm. That space is the future of labor. And defending it is not a matter of preference. It is a matter of survival. Thank you for your attention. I welcome your questions. This condensed speech accompanies the 14-slide presentation